Now we'll be looking at the laws of indices. So first off, what is indices? This refers to an exponent or superscript number appended to a number. So indices just represents a form in which we express numbers. As you can see in this case, you have 5 to the power of 3. And what does this tell us? Tells us that we should multiply 5 3 times. So in this form, the bigger number or this number here is referred to as the base, while the exponent or the power is referred to as the exponent or power, the smaller number up. So a number written in this form is written in indices form. And why do we write number in this form? As we see, writing numbers in this form enables us to simplify expressions and work with expressions more easily. And to do this, there are some laws that have been defined to help us with simplification of indices, and we're going to be talking about the laws of indices. So what is the first law? It tells us that x to the power of a multiplied by x to the power of b is equals to x to the power of a plus b. To explain this, let's look at this example, simple example. So let's say 2 raised to the power 2 multiplied by 2 raised to the power 3. If I ask you to solve this, how would you go about this? You will say 2 squared is 2 times 2, which is 4. Then multiply by 2 cubed is 2 times 2 times 2, which is 8. Then you will say 4 times 8, which is equals to what? 32. So that answer is what? 32. But rather than going through these means, the laws of indices gives us a way to simplify it directly. So it says when I'm multiplying two numbers together that has the same base, what do? You just pick one of the number and you sum the exponent. So in this case, it will be 2 to the power of 2 plus 3, and that is what? 2 raised to the power 5. And 2 raised to the power 5 is same as 32. How does this come in really handy? For example, if I'm giving something like, say, 7 raised to the power 15 multiplied by 7 raised to the power 12, obviously you cannot try to simplify this or expand this and expand this before you multiply them. That will be too cumbersome. But with the law of indices, I know that this will just be equals to 7 to the power of 12, 15 plus 12, and that will be equals to what? 7 to the power of 27. So that is what the first law of indices is all about. Now let's move on to the second law. So the second law says when you have two numbers and they have the same base and there's a division between them, all you have to do is to subtract. So to give you a good idea, let's examine this example. If I ask you to solve 2 raised to the power 3 divided by 2 raised to the power 2, what would you do? You will say 2 cubed is 8 and 2 squared is 4. Now 8 divided by 4 will give you 2, so you know the answer is 2. But the law of indices, we can solve this quicker. So this will be what? 2 to the power of, since they have the same base, we just have to subtract the exponent 3 minus 2, and that will give me 2 raised to the power 1, which is equals to 2. Again, it comes in handy when I'm trying to solve numbers that are very large. For example, if I have 7 raised to the power 15 divided by 7 raised to the power 10, I know that this will just be what? 7 raised to the power 15 minus 10, which is equals to what? 7 raised to the power 5. Now onto the third law. The third law tells us that anything raised to the power of 0 is 1. And I'm sure that you must have heard this or worked with this before. Anything to the power of 0 is 1. So if I have 3 raised to the power 0 is equals to 1. If I have 5 to the power of 0 is equals to 1. If I have minus 3.1 to the power of 0 is 1. So any number you can think of, provided I'm raising it to the power of 0, it equals to 1. We're not going to go through the proof of this, which is very interesting by the way, but you just need to know this. Now let's move on to the fourth law. And the fourth law tells us that x to the power of minus a is equals to 1 over x to the power of a. What this means in essence is that when you have a minus exponent, like a minus in the exponent, you have to find the reciprocal of the number. For instance, if I give you x to the power of minus 1, you know that this is same as writing 1 over x. But now, if it is not 1 that is here, let's say a number a now, so I just have to find the reciprocal and remove the negative sign. So that will be 1 over x to the power of a. So for example, if I'm giving something like 7 to the power of minus 3, I know that this is the same thing as writing reciprocal over, then I take away the minus sign, 7 raised to the power 3. Similarly, if I have 3 raised to the power minus 4 over 3, I know that this is the same thing as writing 1 over 3 raised to the power 4 over 3. So that is all about the fourth law. Now onto the fifth law. It tells us that if we have x to the power of a, then all raised to the power of b, we can say is equals to x raised to the power a times b equals to x raised to the power ab. To explain it, let me give you a simple example. Let's say I give you something like 2 raised to the power 2 all raised to the power 3. The normal way you go about it is by asking yourself, what is 2 squared? You know 2 squared is 4. So you write down and you find the cube of 4. Then what is the cube of 4? The cube of 4 is 64. But with the law of indices, this is not in particular, I can solve it more directly. So instead of going through this, I can just say, since the exponent, I can just multiply the exponents together. So this is the same thing as saying 2 raised to the power 2 times 3, which is equals to 2 raised to the power 6, and 2 raised to the power 6 is equals to 64. So in the same regards, 3 raised to the power half all raised to the power 4 over 2, 4 over 3 rather, is the same thing as saying 3 raised to the power half times 4 over 3, which is equals to what? 3 raised to the power 4 over 6, and you can simplify it to the lowest term if you want. Now onto the next law. So the next law tells us that if we have x to the power of a reciprocal now, that is equals to the square, the root of that reciprocal of that exponent of x. So what does this mean? In essence, what this means, for example, if I give you something like, say, x raised to the power 1 over 2, then you know that this is the square root, then you take the exponent here 2 and you have x. So x raised to the power half is the same thing as saying what is the square root of x. In that regard, x raised to the power 1 over 3 will be equals to what? The cube root in this case now of x. Now what if I say x raised to the power minus 1 over 5? Now I will have to first apply the first root to remove the minus sign. So to remove the minus sign, I need to find the reciprocal. So this is same as saying 1 over x raised to the power 1 over 5, and I know that x raised to the power 1 over 5 is the same thing as the root, the fifth root of x, which is equals to 1 over, then here will be 5 and x. So it goes on and on and on, just to understand this way. So now let's move on to the last law of indices, and the last law tells us that if I have x to the raised to the power of a over b, then it's going to be equals to square root the root b of x to the power of a, or the root b of x then always power of a, or the root b of x is power of a. So what does it mean in essence? So example, if I have, say, 7 raised to the power 3 over 2 is equals to, in this case, the square root, since it's a 2, I don't need to put the sign. We know this is the square root of 7 cube. I can either do it this way, or I can write it this way also. I'll first find the square root of 7, then I'll now find the cube as defined by this formula. So this is equivalent to this. Any form you choose to write it, it means the same thing. So that is what it means. So for example, let's say I give you an example and I say, okay, find let's say 8 raised to the power minus 2 over 5. Now, as you know, we first have to remove the minus sign, and that will be done by what? Finding the reciprocal. So that will be 1 over 8 raised to the power 2 over 5. And now we can very well apply this law. So that will be 1 over, you know that 8 raised to the power 2 over 5 will be equals to the fifth root of 8, then all squared, based on this law. So to be able to simplify equations, you need to memorize and put to memory the laws of indices. And how do we use them to solve questions? That is what we'll be considering now. So how do we solve equations with indices? So now let's look at this first example. The important thing to note is that we have to know how to apply the laws appropriately. So we are given x to the power of minus 2 over 3 is equals to 9. And we are told to find x, trying to find x. So what can we do? So to find this, we need to remove this exponent away from here. So we'll be left with x. And how can we do that? We need to multiply both exponents by a number that will remove or change this to 1. What do I mean by that? So this is same thing as saying x to the power of minus 2 over 3 is equals to 9 to the power of 1. So now you ask yourself, what can I multiply by this exponent by that will make here equals to 1? And if you think about it, let's call that number x. So what would I multiply minus 3 over 2 by? Or let's call it y, since x is already here, in which the exponent here will be equals to 1. So in that case, when I cross multiply, I see that minus 2y is equals to 3, and I see that y is equals to minus 3 over 2. So if I multiply this number here by minus 3 over 2, then what am I going? I'm going to get 1. So to remove the exponent, all you have to do is just to multiply it by the reciprocal of the same number. So you do that to both sides of the equation. So what does this become now? So you multiply both sides by the reciprocal of what is in x. So you have x raised power minus 2 over 3, then times the reciprocal of this will be what? Minus 3 over 2 is equals to 9 raised power 1 times minus 3 over 2. Remember, you have to do it to both sides. So in this case, this cancel this. Minus times minus is plus 3 cancel 3. So I have x is equals to 9 raised power. This time this is what? Minus 3 over 2. Now, I can apply my laws of indices. To remove the minus sign, I need to change it to the reciprocal. So this is the same thing as saying, according to that law, 1 over 9 raised to power 3 over 2. And if you remember our last law, this is the same thing as saying 1 over then the square root of 9 all raised to power of 3 is based on the 7th law. Can revise it. So this will be equals to what? 1 over what is the square root of 9? The square root of 9 is 3. So 3 cubed. And what is 3 cubed? 27. So x is equals to 1 over 27. Now let's move on to another example. And here we are told also to solve for x. And this should be pretty straightforward likewise. So let's get started. First and foremost, as you know, we have to make x to be in one side. So how can we do that? We can divide both sides by x to the power of minus 1 over 3. So if I divide both sides by x to the power of minus 1 over 3 and I divide here by x power of minus 1 over 3, then this cancel this. So I'm left with 5x over x is power minus 1 over 3 is equals to 80. Now I can divide both sides by 5 so that I can eliminate 5 from this side. So if I divide both sides by 5 and I divide both sides by 5, I have x over x is power minus 1 over 3 is equals to 80 over 5, which is equals to 16. Now how do I deal with this? Now I can write this normally as x divided by x is power minus 1 over 3 as being equals to 16. Now if you think about it, this is our second law of indices that tells us that is the division sign and the base are the same. In this case x, we just have to subtract the exponent. So in this case, we know that this x is raised to the power of 1, so but we didn't write it because there is no need to have x to the power of 1. Then based on the second law, we change this divide to minus, then minus here we have minus 1 over 3 is equals to 16. So we know that minus times minus is plus, so we're left with x to the power of 1 plus 1 over 3 is equals to 16. So what does this give me? This gives me x 1 plus 1 over 3 is 4 over 3 is equals to 16. Now I want to remove the exponent away from here. So what did I say we have to do? We have to multiply both exponents, both sides of the exponent by the reciprocal of this. And what is the reciprocal of 4 over 3? The reciprocal of 4 over 3 is 3 over 4. So I multiply here by 3 over 4 and I multiply the reciprocal here by 3 over 4. So it cancels out neatly. So I have x is equals to 16 raised to power 3 over 4. Now based on my the last law, the seventh law of indices, we are told that if you have a number, let's say a number x raised to the power of a over b is equals to what? Is equals to this root b of x to the power of a. So in this case now I can simplify this since I have 16. So my x in this case will be equals to, my b here is 4, so the fourth root of the number, which is what, x in this case, which is 16, all raised to the power of 3. Now the cube root, the fourth root of 16 means what number can I multiply 4 times to get 16? And the answer to that is 2. If I multiply 2 4 times, 2 times 2 times 2 times 2, I'm going to get 16. So it's either plus or minus 2, because if you multiply minus 2 4 times, you also get 16. But I'm just going to stick to the positive root. So it's going to be 2, and I now find the cube of 2. And what is the cube of 2? The cube of 2 is 8. So x in this case is equals to 8. So if we substitute 8 into this equation now, you are going to find out that this expression is equal. Now let's look at another example on how to apply it. So now we are told that 3 raised power 2x is equals to 9 raised power 2x minus 3. So what is our goal in solving questions like this? Our goal is to make sure that the base in both sides of the equation are equal. I want to make sure that the base are equal. And how do we go about that? First and foremost, I ask myself, what number, how can I make it equal? And if I look at 9, I see that I can write 9 in form of 3, because I know that 9 is equals to 3 squared. So I do this and I have 3 raised power 2x is equals to 9 is the same thing as 3 squared. So remember to put what was there before in bracket, so you will be able to multiply completely. So this is equals to this because I've converted 9 to 3 squared. So now I can multiply those two exponents together based on one of the laws of indices. So now I can have 3 raised power 2x is equals to 3 raised power 2 times 2x, 4x, then 2 times this, I have minus 6. Now what do I do? Imagine a scenario in which I tell you, for example, that, let me write that here, that 4 raised power x is equals to 4 raised power y. Now you know that the base, these two numbers are equal. You know that the base of these two numbers are equal. So for this condition to be fully satisfied, then x must be equals to y. If x is 2, y must be equals to 2, because 4 raised power 2 is equals to 4 raised power 3. But if x is 2 and y is 3, then you have 4 raised power 2 and 4 raised power 3, and clearly these equations are not equal. So when the base in two sides of the equal signs 2 are equal, then the exponent must also be equal. So now we see that the base are equal in this case. So it follows therefore that the exponents must be equal. So we equate the exponent. So we have 2x also must be equals to 4x minus 6. We call it like time, bring this here. So we have 2x minus 4x is equals to minus 6, which gives me minus 2x is equals to minus 6, and I divide both sides by minus 2, and I have what? X being equals to what? 3. So yeah, my x is equals to 3. So finally, let's solve one more question before we move to some practical JAMB questions that I was able to extract from the past question. So now we are told to find the value of x. So in line with what I've explained before, what do we have to do? We have to make sure that the base in all these are equal. And how do I do that? So I can write it in terms of, I can write 16 now in terms of 4. And what is 16? I know that 16 is equals to what? 4 squared. So I can put it here. So I have, instead of 16, I can write 4 squared. Then I have into bracket 2x plus 5. Then multiply by 4 raised by x is equals to 1. I'm going to come back to this side later on. So now we can expand this. So I have 4 raised power 4x plus 10 times 4 raised by x is equals to 1. If you remember from our law of indices, we say if you are multiplying two indices together and they have the same base, what do you do to the exponents? You just have to sum them up. So I have 4 raised power 4x plus 10 plus x is equals to 1. So 4 raised power 5x plus 10 is equals to 1. Now, how do I deal with this? Before I can equate the exponent in both sides, I need to make sure that their base are equal. But 4 is not equals to 1. But how can I make 1 equals to 4? If you remember from our law of indices that we said anything raised power 0 is equals to 1. So with that, that means I can write 1 as 4 to the power of 0. So 1 is the same thing as what? 4 to the power of 0. If I substitute that here, I have 4 raised power 5x plus 10 being equals to 4 to the power of 0. So now that the base are equal, I can equate the exponent. So I have 5x plus 10 is equals to 0. I have 5x is equals to minus 10. And when you divide both sides by 5, you have x is equals to minus 2. So now we're going to solve some actual questions that are extracted from JAMB questions, and they should be really straightforward. So these are actual JAMB questions that are extracted, so I can give you a feel for what questions look like. So without using tables, we are told to evaluate 343 raised by 1 over 3 times 0.14 raised by minus 1 times 25 raised by minus half. So now from our law of indices, we know that 343 raised by 1 over 3 is the same thing as the cube root of this number. So I can write this as the cube root of 343. Then I know that 0.14 raised by minus 1 is the same thing as saying 1 over 0.14. Then I know that 25 raised by minus 1 over 2 is the same thing as saying 1 over 25 raised by half. So now this follows up nicely to be what? The cubic root of 343 is 7, because when you multiply 7 3 times, you get 343, then times 1 over 0.14, then times 25 raised by half is the same thing as square root of 25. And what does that give me? That gives me 7 times 1 over 0.14, then times 1 over 5. So now 7 will go here 1, and 7 in 0.14 will give me 0.02. Now this will be equals to 1 over 0.02 times 5, and that is equals to 1 over 0.1. So what is 1 divided by 0.1? 1 divided by 0.1 is the same thing as what? 10. You can do that with your calculator, or you can easily do that by converting this to fraction, because you know that this same thing as saying 1 divided by 0.1, and you know that 0.1 is the same thing as 1 over 10. So when you change it to multiplication, you have 1 times 10 over 1, and that is equals to 10. So 1 divided by 0.1 is 10. So what option corresponds to that? I think that's A. So the answer to this question is A. Now let's move on to another example that I extracted from JAMB. So this is actually a past question. So here we are told to solve for x in this expression. So to do that, which is pretty straightforward, we just first and foremost we have to take 8 away from here. So let me write the question out. We have 8x power minus 2 is equals to 2 over 25. So we have x to the power of minus 2 is equals to 2 over, if I divide both sides by 8, so 2 over 25 times 8. Can divide that out. 2 will go here 1, 2 will go here 4. So x is power minus 2 is equals to 1 over, what is 25 times 4? 25 times 4 is 100. So x is power minus 2 is equals to 1 over 100. Now x raised power minus 2, if you remember, to remove the minus sign, I just find the reciprocal from our law of indices. It's the same thing as writing 1 over x squared. So 1 over x squared is equals to 1 over 100. I can easily cross multiply. So when I cross multiply, I have x squared is equals to what? 100. And if you remember, to remove the exponent, what do I say you do? You multiply both sides by the reciprocal. So you multiply here, the reciprocal of 2 is half, and the reciprocal here will be half. So I will have x is equals to 100 raised power half. And from our law of indices, 100 raised power half is the same thing as square root of 100, and that is equals to what? 10. So x is equals to 10. And what option corresponds to that? That will be A. Now let's look at the last question that I'll be solving that has to do with JAMB. So this is also a JAMB question, and we'll try to use the law of indices to tackle it. I told that if 27 raised power x plus 2 divided by 9 raised power x minus plus 1 is equals to 3 raised power 2x, we should find x. So how do we go about it? Now, as I've mentioned, we need to first write everything in the same base, and to do that we can see that we can express 27 and 9 in terms of 3. So we know that 27 is 3 cubed, and we know that 9 is 3 squared. So we can substitute it there. So for 27 we can write 3 cubed, then put in bracket what was there before, x plus 2 divided by 3 squared into bracket x plus 1 is equals to 3 raised power 2x. So now when I expand, I have 3 raised power 3x plus 6 divided by 3 raised power 2x plus 2 is equals to 3 raised power 2x. Now how do I go about this? From my law of indices, if I have the same base and there is a division sign, what do I have to do? You know that I just have to write one of the base and subtract the exponent from each other. So I have 3x plus 6, then minus, don't forget to put in bracket, since you have more than 110, 2x plus 2, then is equals to 3 raised power 2x. So this becomes 3 raised power 3x plus 6, then expand, minus times minus 2x give me minus 2x, then minus times minus plus 2 will give me minus 2 is equals to 3 raised power 2x. Then I simplify. 3x minus 2x will give me x. So I have 3 raised power x plus, and 6 minus 2 will give me 4. 4 is equals to 3 raised power 2x. Now I can see that the bases are equal, and once the bases are equal, what can I do? I can equate the exponent like as I've explained. So I know that x plus 4 is equals to 2x. So if I bring this to the other side, so I have, if I bring this x to the other side, so I have 4 will be equals to what? 2x minus x. So I know that 4 is equals to x, or the same thing as saying x is equals to 4. And what option corresponds to that? B. So the answer in this case is what? B, and we know that what? X is equals to B. So what I would suggest is you do is that you go to the past questions now, and you try to look for questions that are relating to indices and try to tackle them. Also, in the exercises that will be given at the end of the section, you also find questions that are relating to indices from the JAMB past question. So that will be all for now.